So in today's class, we'll pictorially study how to represent an entity, how to represent a relationship, how to represent an attribute, and so on. Right. So today's class will be about working with ER diagrams. So we have a special software called Unified Modeling Language to design ER diagrams. Right. So so the topic is going to be ER diagrams. So we'll study how to represent an entity set by means of an ER diagram. Right. So entities can be graphically represented as follows. So rectangles, they are used to represent entity sets. Right. So rectangles are used to represent entity sets, and attributes are listed inside the entity rectangle. So you have an underline which indicates the primary key attribute, right? So for example, you have two different entity sets, student entity and instructor entity, right? So student entity is represented by a rectangle, and attributes are listed inside the entity, right? So the student entity set, the different attributes are going to be ID, student ID, name of the student, total credits is enrolled in a semester, and so on. So here underline in an attribute indicates that it's a primary key, right? So student ID is a primary key of this student entity set. So rectangles are used to represent entity, and attributes are represented are listed inside the entity rectangle, right? So this is how you represent an entity set, right? So now how to represent a relationship set, right? So there exists some relationship set between the participating entities, right? So in an university, you have the entity sets. The two important entity sets in an university are going to be a student and the instructor, right? A student is characterized by the attributes ID, name, and total credits, whereas the instructor is again characterized by the employee ID or ID, name, and salary, right? So there exists the relationship between the participating entities, right? So here there exists some binary relationship between the participating entities. So there exists an advisor relationship between the instructor and the student, right? So an instructor may act as a staff advisor for a few students in a class. So we use diamonds to represent the relationship set, right? So diamonds are used to represent the relationship set, and it is used to represent the relationship between the participating entities, right? So rectangles are used to represent entity set, diamonds are used to represent the relationship set, right? So you can also associate some attributes with the relationship sets. So whenever you are going to associate an attribute with the relationship set, it is given by again a dotted representation of the attributes. So for example, an instructor is associated with a student as an advisor from some starting date, right? So the attributes can be associated with the relationship sets also. It is connected with the attributes by means of a dotted symbols, right? So again, so last class we discussed about the different cardinality constraints that exist between the different entity sets, right? So there exists one-to-one relationship, or one-to-many, or many-to-many, or many-to-one relationship between the participating entities, right? So we express the cardinality constraints by drawing either a directed line signifying one, or undirected line signifying many between the relationship sets, right? So if there exists an arrow symbol, it denotes one, whereas if it is going to be a undirected line, it represents many relationship between the participating entities. So in this example, we have arrows in both sides. So it means that there exists one-to-one relationship between the instructor and a student, right? So a student is associated with at most one instructor, via the relationship advisor, right? So each and every student or a student is associated with only one instructor through the relationship advisor, right? So a student is associated with at most one department via student department, right? So we have, whenever you have one-to-one relationship, you are going to use directed lines, you use arrows to represent it. Whereas if there is going to be many, the many symbol is represented by undirected line, right? So for example, here you have one-to-many relationship. You have one instructor, you have many students. So this is how you represent your one-to-many relationship between the instructor and your student, right? So you have one instructor, he is associated with a group of students, right? So an instructor is associated with several students via advisor. You have this one-to-many relationship, right? So you can also represent many-to-many relationship using undirected lines, right? So in many-to-many relationship between an instructor and a student, an instructor is associated with at most one student via an advisor, and a student is associated with several instructors via advisor, right? So a student may have different advisors for different activities or courses, and maybe again the instructor may be also act as different he may be associated with different students, more than one student via the advisor role, right? So sorry, this is many to one relationship, right? So this is many to one relationship, and the next we have many to many relationship, right? So you have many students associated with several instructors via the advisor role, and similarly an instructor is associated with several students via the advisor role, right? So directed edges, it represents one relationship, whereas if it is going to be an undirected edge, it represents a many relationship. So whenever you have some entities and there exists some relationship between the entities, which may be of one-to-one relationship, one-to-many relationship, many-to-many relationship, so we'll be using edges with arrows and undirected edges to represent the relationship between the participating entities, right? So again, the next thing that you need to know in an ER diagram is that how to represent total and partial participation, right? So the total participation is indicated by a double line, right? So total participation means every entity in the entity set participates in at least one relationship in the relationship set, right? So each and every student, so here the student entity set, we have double lines, which indicates that it's going to be a total participation between the students and the instructor as an advisor. So it means that every student is associated with some faculty as an advisor, right? So here the participation for the student entity is going to be total participation, whereas here you have a single line for instructor, which indicates that the participation may be partial participation, right? So some entities may not participate in any relationship in the relationship set, right? So only few faculty members or few instructors, they are associated with the students through the advisor role, right? So all the instructors, they may not be advisors for students. Only a subset of faculty members or instructors, they are going to be associated with students as the class advisors or they are going to play the role of advisors for students. So here the participation of advisor role for a faculty is going to be partial participation. So we are represented by a single line, whereas all the students in an institute, they are being associated with an instructor through this advisor relationship. So there exists full participation among the participating entities for the student relation, right? Right. So now we'll extend the notion to represent entity with complex attributes, right? So you all know that some attributes are complex. So the attributes which are divisible, they are known as complex attributes, right? So for example, the name of a instructor is going to be divisible, right? So the name attribute of an instructor can be given as first name, middle name, last name. So this is how we represent a composite attribute or a complex attribute in a entity, right? So name is a complex attribute. Similarly, the address is again a complex attribute. Right. So this diagram is an extension of an entity model, entity set model. Here we are going to represent again. You are going to represent an entity set by means of a rectangle. The only thing is that the attributes are represented inside the rectangles, and here we are going to represent the complex attributes. So name is a complex attribute and address is a complex attribute, right? So so name is a complex attribute which can be further subdivided into first name, middle name, last name. Street is a complex attribute which can be further subdivided into street number, street name, apartment number, and so on, right? Then we use some multi-valued attributes, right? So for example, contact number, phone number of a particular instructor is going to be a multi-valued attribute. So it is given within curly braces, right? So you know that in the case of multi-valued attributes, an entity can have more than an attribute can have more than one value for this particular attribute, right? So a person may have more than one contact number. So it is represented by the attribute within curly braces, right? So you have an attribute date of birth, you have an function age, right? So the age can be calculated, right, from the date of birth attribute as well as the current date, right? So you can also have some simple functions that can be used to derive some new attributes, right? So anyway, this is how you represent an entity with complex attributes, right? So the next thing is that expressing weak entity, right? So weak entity is represented by a double rectangle symbol, right? So what do you mean by a weak entity? So last class we discussed about weak entity, and entity without a primary key of its own is known as weak entity, right? Whereas strong entity means it's an entity that has a primary key of its own. So for example, course is a strong entity, whereas section is a weak entity, right? So for example, if I have a section alone, section ID, let us assume that the section ID is going to be a section, semester is going to be a sixth semester, or now it's fifth semester, year is going to be third year, right? So with this section entity alone, it's very difficult to identify which department the section is associated with it, because it's going to be it does not have any primary key of its own. So it is dependent on this strong entity course, right? So course ID is going to be a primary key for the strong entity course. So the course entity set has its own attributes, title and credits, right? So the weak entity is one that does not have a primary key of its own. So section is a weak entity, right? So with this information, I may not know whether the section is for the course database management system, or it's for the course artificial intelligence and machine learning, right? So it's very difficult for me to get the information, right, about the particular section, because a section is going to be duplicated. So it does not have any primary key of its own. Section name, section ID is going to be it's not unique, right? Section A, semester is going to be fifth semester, and a year is going to be third year. So I will not be able to identify which section it is. So only if I associate a section with the particular course, I'll be able to get more information about the particular course, right? So whenever you have a weak entity, an entity that does not have a primary key of its own, you are going to represent it by means of double rectangle symbol, and we underline the discriminator of a weak entity set with a dashed line, right? So the relationship connecting the weak entity set to the identifying strong entity set is depicted by a double diamond, right? So again, we are going to use whenever you need to represent a relationship set, we have a single diamond. Whereas whenever I need to connect a weak entity set with a strong entity set, I need to represent it by means of a double diamond symbol. So here the primary key for section is going to be course ID, section ID, semester and year, right? So this is how we represent this section. We are going to have the union of the primary key of the strong entity with all the attributes in the weak entity, right? So we'll study about how to represent weak entity in a relation schema in our later slides, right? So this is an ER diagram for an university enterprise, right? So let us assume that you are expected to represent an university in the form of a database schema. So we go for a ER diagram to represent the schema design of a university. So here the important entity sets are going to be student entity set, which contains student ID, name, and total credits the student has enrolled. We have instructor entity set. So the instructor is identified by ID, name, and salary. We have department entity set, department name, right? It also contains the building name of the department and budget of the department, right? So we also have course entity set, course ID, title, credits. So whatever entity set we have discussed till now, it's going to be a strong entity set. We also have a weak entity set section, which contains the attribute section ID, section ID, year, right? So whenever you have a weak entity, it is represented by double rectangle symbol. And whenever you have a relationship between a strong entity and a weak entity, the relationship set is again represented by double diamond symbol, right? So this is how we have constructed an ER diagram for a university enterprise.